Week 4 focused on answering the question, where do we get our energy from now? In particular, we explored these questions. What is a primary energy source? Which primary energy sources contributed most to the U.S. energy system, the world energy system, the energy systems of other countries, and Maine's energy system? How are these energy sources extracted from their natural state and converted into usable products? Which energy sources are imported and exported? Which countries are the major producers of which energy sources? And how long will these resources last? This question was actually answered in the Week 3 recap video. A primary energy source is energy in the form that is first accounted for in a statistical energy balance, before any transformation to secondary or tertiary forms of energy. For example, coal can be converted to synthetic gas, which can be converted to electricity. In this example, coal is primary energy, synthetic gas is secondary energy, and electricity is tertiary energy. In the Week 3 recap video, you viewed a list of primary renewable and non-renewable energy sources. This week you explored 3 websites to learn which primary energy sources contributed most to the U.S. energy system, the world energy system, the energy systems of other countries, and Maine's energy system. The results of your exploration should have revealed that the U.S. and the world are powered mostly by fossil fuels, oil, coal, and natural gas, with oil contributing the most to both energy systems. Maine is also primarily powered by oil, with 45% of primary energy input to the system coming from oil. This percentage is higher than the national average due to the large amount of fuel oil used in home heating in Maine. However, only about 60% of the primary energy input to Maine's system comes from fossil fuels because Maine relies heavily on biomass and hydro, causing renewables to make up 38% of Maine's primary energy input. This is a much larger percentage than that of the U.S. or the world, where renewables make up only 7 to 10% of the primary energy input. Next, you looked at how these energy sources are extracted from their natural state and converted into usable products. You watched a series of videos and did a series of readings on this subject for the largest contributors to the U.S. and the world energy systems: oil, coal, and natural gas. You learned that coal was formed over millions of years from heat and pressure, turning decaying biomass into different forms of coal. Lignite, which has the lowest carbon heat content, lowest combustion temperature. Bituminous coal, which is the most plentiful type, has a high sulfur content and is used to generate electricity. And anthracite, which has the highest carbon heat content, the highest combustion temperature, and is used in home heating in the Western Hemisphere and for electricity in Asia. There is also subbituminous coal, which has a lower heating value than bituminous coal. About 44% of the coal produced in the United States is subbituminous, and most of the rest is bituminous. Understanding that there are different types of coal is important because the amount of energy and type of pollutants that come from coal greatly depend on the type of coal that is being burned. Coal can be extracted through many different methods. Surface mining, including mountaintop removal, is used to produce most of the coal in the United States because it is less expensive than underground mining. Surface mining can be used when the coal is buried less than 200 feet underground. In surface mining, giant machines remove the topsoil and layers of rock known as overburden to expose the coal seam. Once the mining is finished, the dirt and rock are returned to the pit. The topsoil is replaced and the area is replanted. Underground mining, sometimes called deep mining, is used when the coal is buried several hundred feet below the surface. Some underground mines are 1,000 feet deep. To remove coal in these underground mines, miners ride elevators down deep mine shafts, where they run machines that dig out the coal. After coal comes out of the ground, it typically goes on a conveyor belt to a preparation plant that is located at the mining site. The plant cleans and processes coal to remove other rocks and dirt, ash, sulfur, and unwanted materials, increasing the heating value of the coal. After coal is mined and processed, it is ready to be shipped to the market. The cost of shipping coal can be more than the cost of mining it. About 72% of coal delivered in the United States is transported, for at least part of its trip, to market by train. Coal can also be transported by barge, ship, truck, and even pipeline. Oil and natural gas were also formed by dead plants and animals compressing over millions of years. Today we extract oil and natural gas by drilling underground in land and water into rock formations that contain oil and gas deposits. After crude oil is removed from the ground, it is sent to a refinery by pipeline, ship, or barge. At a refinery, different parts of the crude oil are separated into usable petroleum products. Crude oil is measured in barrels, abbreviated BBLS. A 42 U.S. gallon barrel of crude oil provides about 45 gallons of petroleum products. This gain from processing the crude oil is similar to what happens to popcorn, which gets bigger after it is popped. Gasoline makes up the largest proportion of the products made from a barrel of crude oil, followed by diesel and other products including ink, crayons, dishwashing liquids, deodorant, eyeglasses, CDs and DVDs, tires, ammonia, and even heart valves, among other things. Just like coal, not all crude oil is the same. In simple terms, crude oils are classified by their density and sulfur content. Less dense or lighter crudes generally have a higher share of light hydrocarbons, from which higher value products such as gasoline, jet fuel, and diesel can be recovered with simple distillation. The denser or heavier crude oils produce a greater share of the lower valued products with simple distillation and require additional processing to produce the desired range of products. Some crude oils also have a higher sulfur content, with an undesirable characteristic with respect to both processing and product quality. Conventional natural gas is either extracted from the space above an oil deposit or from a pocket of natural gas on its own. Shale gas is extracted by drilling vertically and then horizontally into a shale formation that holds tiny pockets of natural gas inside the shale. These pockets are released by fracturing the shale rock, a process known as fracking. This technology has been around for a long time, but it just recently became cost-effective to do commercially. Today we hear a lot about the advantages and disadvantages of shale gas, something we will explore more in Unit 2. Natural gas is processed to remove unwanted products and then compressed to be able to travel by pipeline. It can also be chilled to a very cold temperature and turned into a liquid, which allows it to be shipped via truck, rail, and barge. Natural gas pipelines comprise an immense network of over 200,000 miles. As you can see from this map, very little of that network makes its way up to New England and even less of it to Maine. This is the primary reason why New Englanders and Mainers in particular still rely on fuel oil for their home heating needs, and why natural gas prices can still be very expensive in this region of the United States, while they are very cheap in other areas of the country. The next question you explored was which energy sources are imported and exported. As you probably expected, coal exports exceed coal imports because we have a lot of coal in the United States. Our coal comes from three major regions: Appalachian, Interior, and Western. Over half of the U.S. coal is produced in the Western region, and the Appalachian region accounts for more than a third of the U.S. coal production. Coal is mined in 25 states. Wyoming mines the most coal, followed by West Virginia, Kentucky, Pennsylvania, and Texas. Of the 999.1 million short tons of coal consumed in the United States in 2011, about 1% was imported, mostly from South America. In 2011, the amount of coal imported to the United States was about 12% of the amount exported to other countries. It may be more surprising to learn that we actually produce more oil than we import, and most of the oil we import actually comes from Canada and not the Middle East. However, political issues in the Middle East are still important, even though that is not where we get most of our oil. That is because the price of oil is set in a global market, and political events in one area, even if it is not an area that we normally get our oil, affect oil prices for the whole world. We will explore this issue more in Unit 3. The U.S. is a net importer of crude oil, but a net exporter of petroleum products because we do a lot of refining in our country. The U.S. is a net importer of natural gas. We consume more natural gas than we produce. However, reliance on natural gas imports has declined in recent years due to a surge in natural gas production, resulting from more efficient, cost-effective drilling techniques, notably in the production of natural gas from shale formations. Net imports, or imports minus exports, of natural gas accounted for 6% of U.S. natural gas consumption in 2012, compared to the 2007 peak of 16%. Next, you looked at which countries are major producers of each energy source. In terms of the major producers that supply fossil fuels to the U.S. is on the list because it produces much of its own, and this page lists the other countries that provide coal, oil, and natural gas to the United States. Finally, you looked at how much each of the energy sources remains to be extracted. This is a tricky question to answer because it depends on if you're talking about resources or reserves. Resources are a larger quantity that consists of an amount that is thought to exist and could possibly be feasible and/or economical to extract. But reserves are more well known and can be extracted under existing conditions. So reserve numbers will be smaller than resource numbers. Based on U.S. coal production for 2011, the U.S. estimated recoverable coal reserves represented enough coal to last 236 years. However, the United States Energy Information Administration, EIA, projects in the most recent Annual Energy Outlook from April 2013 that U.S. coal production will increase at about 0.2% per year for the period 2011 to 2040. If that growth rate continues into the future, U.S. estimated recoverable coal reserves would be exhausted in about 194 years if no new reserves are added. Worldwide, compared to all other fossil fuels, coal is the most abundant and is widely distributed across the continents. The estimate for the world's total recoverable reserves of coal as of January 1, 2009, was 948 billion short tons. The resulting ratio of coal reserves to consumption is approximately 129 years, meaning that at current rates of consumption, current coal reserves could last that long. So we are not running out of coal anytime soon. The U.S. Energy Information Administration estimates that there are 2,203 trillion cubic feet, or TCF, of natural gas that is technically recoverable in the United States. At the rate of U.S. natural gas consumption in 2011 of about 24 TCF per year, 2,203 TCF of natural gas is enough to last about 92 years. There were an estimated 6,707 TCF of total world proved reserved of dry natural gas at the end of 2011. There is still a lot of oil in the world. As shown in EIA's International Energy Outlook 2013, the global supply of crude oil, other liquid hydrocarbons, and biofuels is expected to be adequate to meet the world's demand for liquid fuels for at least the next 25 years. Now that you have a basic understanding of the current state of our energy systems, we will be heading into Unit 2 to learn more about how we can change the current electricity system to be more sustainable. Before starting Unit 2, however, please make sure to take the Unit 1 exam, which is available in the Unit 1 folder beginning on February 6th at 8 a.m. and ending February 9th at 11:59 p.m.